Welcome to 2911. That's amazingly quiet. Well done. Look, that reminds me of something. Years and years ago, I was doing a show, and we had to get an eerie, spooky silence in the middle of the show. And it had to feel spooky. It was maybe it was a tempest or something weird. But we had no budget. And of course, silence is quite hard to manufacture. So, after thinking about it long and hard, what I did was I set up big speakers all around the hall for the big storm scene, enormous big woofery things all around the hall. And for the whole first half of the show, I had them turned on. And all you could hear was just like the static, the hiss, soft coming out of them. And within a few minutes of starting the show, you just tuned that out. You just ignored that sound. And then when it got to the silent bit, at the power switch, we turned them off. And the sound you'd been taken as the base level of silence suddenly was noisier than the sound that you were hearing now. Does that make sense? That's an example of something called design. We had a problem. We had a constrained budget, limited resources. We didn't solve it by buying more powerful computers or knowing fancier programming languages. We solved it in our heads. We solved it using our wits, our design ability. And that's what this course is about. You've already done first year, and in first year you've seen how to program. You've fooled around a lot with C. You've learnt lots of technical skills, and that's really excellent because you need those skills. But we're going to see in this course that that's not enough. That actually won't solve most of the real world problems that are in the real world. And that we need more. We don't need less. We couldn't get away without that stuff, and I'm really proud of you guys having technical mastery. But in this course we're going to be looking at, I don't want to say the bigger picture, so I'm not going to say it. Can someone tell me what can I say? We're going to be looking at another dimension, the 8th dimension. What are we looking at? Another angle? We're taking a step back. We're doing something qualitative rather than something quantitative. We're just looking at, well, I don't even know how to say it. Let's actually just do it rather than talk about it. Okay, so welcome to the course. This is COMP2911. Java. This is a Java course. We'll be teaching Java in this course. It's a course about Java. Has anyone heard of Java before? Java was a language invented by James Gosling at Sun in 1950. Here is a Hello World program in Java. No. That's rubbish. This is not that course. We're not, it came back. It's that course. We're not doing a Java course, and I live in fear that in the years I don't teach this course, the people that teach it might see that we use the language Java and might think it's a Java course. I might sit down and teach you all Java and do nothing but Java, and I hope that's not what you think this course is about. This is in fact Hello World in Java, but we're going to not look at that, because in fact this is a course about object orientation. Now dictionary.com defines object-oriented as pertaining to or denoting a system, programming language, etc., that supports the use of objects as an entire image, a routine, or as a data structure. And that's rubbish too, so we're going to get rid of that. This isn't even... And often when people talk about this course, they say, oh, you're doing 2911, that's the object-oriented course, or that's the Java course. But no, 2911 is a design course. And one of the things we'll be doing when we design complex systems is we'll be using object-oriented methodologies because they're really neat for solving certain sorts of problems. So you need to see them at some point. So this is a really nice point in your career to see them. And we have to use a language. We can't just talk about object orientation without using a language. So we'll be using Java, but this is not a Java course. And this is not an object-oriented course. This is a design course. Okay. So let's now go to the, who's new? Who haven't I seen before? Because there's some unfamiliar, who have I taught before? Who's come here from COMP2911? Well done. Welcome back, guys. It's very nice to see familiar faces. Normally at the start of a course, it's a whole lot of new faces, and I have to puzzle about you, but I've already, got detailed dossiers on most of you, and that makes my job much easier. He said, shit, it's not in your dossier that you swear. This is fantastic. Pencils, I've forgotten them, because what I wanted on my Mac was some sort of application for taking quick notes wherever I was, even if my battery wasn't working. So now I just, and it's got all these smooth surfaces. You can, it's incredible. I'm going to patent it. Who's come here from somewhere else? Where are you from?
Summer session.
Ah, you did summer session 1927 with Angela. She's fantastic, isn't she? Yes. Angela, who's ever been taught or tutored by Angela? Yeah. Okay. When were you guys taught by her? She did 1917. She did a tute. Oh, yeah. What do you think? Yeah, she's really nice. She's an incredibly nice and patient and caring person. So I was so pleased she took summer session, and it was a nice session and you had a good time. Who else is here that's new? So welcome to 2911. Who else is here that hasn't been in the mainstream? Yeah, where are you from? Summer session as well. Who else is from summer session? Okay, you. And there was someone up here? Wait, one there, one there. And you guys are in summer session because you came halfway through the year, or maybe you're not doing computing, you're doing something else or something. Is there anyone here not doing a computing degree? Where are you from? The guy with the, yeah. Were you waving at me or just? No. But I don't know you, do I? No, where are you from? You're a computer science student, but you didn't do 1927? With us? What course did you do last semester?
Something to do with Perl.
Perl. Oh, 2041 maybe. Yeah. Okay. Well, welcome to 2911. And engineering. Okay. Oh, just undecided engineering. You haven't picked a major yet, or mechanical engineering? Okay, mechatronics is cool too. All right, well done. Well, welcome here, and do feel part of the whole group and things. Like everyone, be welcoming, because it's very hard to be the one mechatronic person in a room full of computing people, and it's an incredibly brave thing to do, and an incredibly good thing to do, because I think it's really important to learn lots of different things, not just one thing. So, welcome everyone. I'm really looking forward to teaching this course because it's probably the most interesting of the courses from my point of view. When we designed the courses years ago and split the material over the three courses, 1917, 1927 and 2911, all the time when we were debating about which topic went in which course, I was secretly hoping that I would be the one that got to teach 2911 every year. But the way it's turned out, I hardly ever get to teach this course, so it's a real pleasure to be teaching it now. This is our homepage. Has everyone seen the homepage already? It's set up like those of you that have been here with us already. The important things to notice are the stop press, where I will post important notices from time to time, so do check that. And this link here, which tells you about the course in general, and this link here, which tells you about the course for this particular session, what's unique about this particular session, and then our schedule, which is where everything comes from. And to enroll in, to go to the forum, you click on this one over here, discuss. Let's go to the schedule because everything's there. There's lots of interesting colours on the schedule this year. It's very strange. And have you noticed the weeks aren't numbered 1, 2, 3, 4? The weeks are numbered 1.0, 1.1, 1.2, 1.3, and then 2.0 when the colour changed, 2.1, 2.2, 2.3, 3.1. What we've done is we're following the ancient academic tradition of splitting the semester into 3 equal-sized periods, each of 4 weeks, called platypiads, which is a fairly unusual name. In each platypiad, something different will be happening. From your point of view. You'll be having programming partners that you'll be working with, and that'll switch around each platypiad. Also, there's a design assignment that we'll be working on over the course, and each platypiad will change the spec a bit of the assignment. So that's something that we'll explain a bit later on. So let's just go to today's lecture. Lecture slides. Let's draft. Let's make it big. Oh, how do I make it big? Ah, there we go. So we've done what the course is about already. So yeah, background. I've got a picture which sort of represents the first 3 courses. I'm not a very good graphic designer, so this picture's a bit crap. Oh, in fact, it doesn't even fit on one screen. Is there some way of making it... what do I do? Control minus? Does that shrink the picture? Oh yeah, perfect. No, it's not shrinking the picture. It's shrinking the words around the picture. Just minus? Right click it, view image. There, thank you. Okay, so here are the 3 courses. COMP2911, in that course you learn how to be a craftsman. In COMP1927 we assume you're still a craftsman, but you learn a bit about how to be a scientist, and we talk about science. And in this final course we're going to be using your craftsman abilities and your science abilities, but we're going to be talking about becoming a designer as well. Now I had a story that I was going to use to introduce this sort of concept of what I mean by designer. And I was a bit foiled this morning. For years, For years I go for a walk every morning, and for a while, at least for 1 year, while I've been doing the walk, I've been watching two houses being constructed, and they're right next to each other. And I'm just interested in houses being constructed, so I always have a bit of a peep over the fence to see what's happening. And an interesting thing started to happen. After a while, I noticed they were being constructed by completely different companies, and the owners were obviously quite different people, and the builders were quite different, because one house was being made out of brick, and one house was being made out of wood. And I was watching them construct it, and the brick house was incredibly impressive. First of all, instead of taking the power lines from the pole to the house, what they did was they covered them in some metal tube and took them down the pipe. Then they dug a big trench to the house and they buried the power cables underneath, so you don't have unsightly power cables going to the house. And from the beginning, when I saw them doing this, I thought, wow, this is a serious renovation. They're doing this quite, the construction's the whole house. They're doing this with a big budget and they want to do a really good job. Whereas the other people just had a rickety old power pole going across to the wooden house. And then as the brick house was being constructed, it was interesting. It was on many levels. There were all these interesting things happening. It was proper double brick. It wasn't brick veneer, so it was two skins of brick, not a skin of brick hiding a skin of wood to pretend to be a brick house, but really to be a wood house inside. And the wood house just looks like a mess. And after a while, I realised what was going on. The guy that was building the brick house is, I think, actually a builder, because even whenever I went there day or night, there'd always be a brickie van parked at the front of the thing, and I figured he was a brickie. And the houses went up, and the one that was the brick house was actually a bit taller than the other one, so it got a bit of a nicer view. And it was just really exciting. And I thought, what I'm going to do is I'm going to talk to you guys about these houses when the course starts and compare the two, and we'll talk about design. So I went there this morning with my digital camera, because the houses presumably are finished, to take a photo of them to show you. And I discovered to my horror that the wooden house looked completely awesome and was beautiful and was nestled in amongst trees, and all the stuff that I thought was just weird, these random bits of wood they had over it, were actually quite nice, and you had these lovely long vistas. And the brick house looked like a monstrosity. It was just like brick all over, and it was brick, and everywhere I looked there were brick, and they'd torn down all the trees, and it was ugly angles, and it just looked foul. And these two houses were next to each other, and one had been made so carefully and nicely, and one didn't look like much effort was going into it, and the one that I had thought was going to be nice was. Does that make sense? So I think the story is, when they built the houses, they used craftsmen, and the craftsmen knew how to make the houses. And the bricklayer clearly is a bricklayer and knows all about laying bricks. I didn't take the photo in the end. I was a bit embarrassed because I didn't want to ridicule the person and show the photos of his house, but maybe I will creep out one day and take a photo and show you. If you're interested in seeing it, let me know. I will take a photo of the two, because it's quite stark. They're next to each other. The bricklayer knew all about laying bricks, so the brickwork's really perfect. It's immaculate. It's square, there's no rubbish on it, the pointing's really nicely done, everything's dead level, everything just looks fantastic. No skimping, really thick lintels used over all the windows, not skimping anywhere, just lovely design. So the guy clearly knows how to build. Furthermore, he obviously had a structural engineer, because there were lots of big structural beams inside. He had some laminated wood holding up one of the floor and a lot of metal, construction prefabricated metals. So they'd have to look up stress charts and work out the forces applied to various things. So they clearly understood the science of building. He was a master builder, and he presumably employed structural engineers, and they got the science of the building just right. But at the end, his house looks disgusting. And this is really what design is about. Design is about solving a problem. So you can get all the little bits right, but you can get the big bit wrong. So I guess that turned out to be a metaphor for the course after all. Somehow, I don't want you guys just to be craftsmen, and I don't want you to just to be craftsmen and scientists, because then you'll build well-written, algorithmically correct programs that aren't what anyone wants, that aren't useful or don't solve useful problems, or that are late and don't get delivered on time. What I want you to do is, sure, be a craftsman, and sure, know about all the algorithms, but at the end of the day, write programs that get used, that are useful, that are delivered on time and do cool things, and are just fantastic and you feel really proud of, that actually solve a problem. So, in a sense, this course could almost be called problem solving, because we're looking at how to solve problems using our skills. Oh, that got very big because we were playing around with pluses. Wow. So, I then sort of wanted to talk about what I meant by craftsmanship, just to quickly revise these three levels: the craftsmanship, the scientist, and then finally the designer. And so for craftsmanship, I was trying to think of something that is constructed with the best of intentions, but just not constructed with much actual skill. Like someone who writes a program that's not a good programmer. And the best example I could think was the poetry I used to write when I was a teenager. I really, really wanted to communicate some ideas, and I felt really, really strongly about some things, so I used to write poems. But then when I looked at them later on, they were so dreadful because I just didn't actually have much of a mastery of the art of writing. So I thought what I'd do is I'd just show you some teen poems and we could look at them and laugh at them. And then I went onto some teen poetry sites and looked at the poems, and I got really upset looking at them because they were very, very emotional about people writing about terrible things that had happened. And I thought, oh, I've forgotten what it was like to be a teenager. And one of them actually made me cry. It was such a sad poem. And I thought, oh. So in a sense, it achieved its goal, even though they're terribly written in their doggerel and they're just rhyming couplets and they're just horrible. So I thought I'd try to find some less poetry that I was less sensitive to that's still crap. So I looked for baby poems. When you get older, your brain does change, and babies do become as wonderful as the other sex probably seems now. But here's some poems about babies. Here's one. Baby, you set my heart on fire. Baby, you burn me right through to my soul. Baby, you are my one desire. This sounds like the Doors, doesn't it? Baby, I love it when you say I love you and whisper those sweet nothings, yet all those sweet nothings, babies are... I don't think that's about babies, you know. I think that was poorly classified. I think that's a love poem. Let's find some more baby poems. I think that was poem number 3. Baby, let's just make it a bit smaller. It's too big. Baby poem number 3. Let's look at that. Oh, no, that's a sad one. No, I read that one. That made me really sad. That's a sad one. You don't read that one. No, that's a sad one too. Oh, man, there's so many sad poems. I'm going to write some crap poems. Maybe that can be an exercise. Could everyone just try and write a really angsty poem about how you're a teenager and you're different to everyone else and no one really understands you and you're alone and different and everyone else is against you? Because that's how we all feel as teenagers, but we also think we're the only one feeling like that. So if you could write some really angsty, terrible poem, and if you could make every second line rhyme with each other, and think of the first line first, so the second line is the forced rhyme, that makes it even better. If you could do that, and maybe we could have a competition for the best teen poetry. So yeah, I'm going to go away from there because all those poems are sad, actually. So that wasn't a good example. So I thought bad poetry was a good example of bad design. Sorry, bad craftsmanship. But of course you could be the world's best person at throwing rhymes together and constructing different meters and not just rhyming every second line. And you could be the best person at constructing a poem. And you could understand all the signs of poems, all the different hexameters and all those different beats and rhythms, and you could completely be a mastery, a scholar, an academic of poetry, but yet your poems could still be crap. Could you accept that as a premise? In fact, I've often seen that I go on teaching courses where people teach us how to be teachers, and I notice they're not good at teaching, the people that are teaching the teaching courses. So even though they know the theory, somehow it doesn't quite work. So, and I know that with academics always criticize books. If you're an English literature person, you write lots of book critiques. Maybe you write lots of critiques about poems and you really understand Shakespeare or you really understand T.S. Eliot, but yet it's very rare that academics themselves publish poetry and it's fantastic. So it's quite possible to have mastered those early steps, but not have that final bit of amazingness that makes an amazing poem. And so we've done the early steps in the course, we're now looking at the amazingness. And I have the last metaphor for the course, and it's Goldilocks and the Three Little Pigs. So you probably know it's a fairly well-known nursery rhyme that there's these 3 little pigs and they're frightened of Goldilocks because she wants to eat them because she loves bacon on her breakfast. So the pigs run and hide, and one of the pigs was a really good craftsman, and he built a beautiful house out of straw on my walk where I go every morning. And this beautiful house was just immaculately made and really nicely woven and all sorts of things like that. And then Goldilocks came up and said, open up little pig, because I want to eat you. And the pig predictably said, no way. And Goldilocks just came in and ate the pig. It's a very sad story. So the first time I told that to my little girl, we all cried a bit. And then I said, But in another universe, because I was teaching her about the theory of parallel universes, and I said, in another universe, two of the pigs cooperated and got together, and one of them was the brilliant craftsman, but the other one was a scientist. And they ran and ran and ran and ran until they got to a hardware store. And the scientist worked out all sorts of forces and charts and angles and corrections and got structured bits of wood that were the right shape to bear various loads and worked out the right jointing systems to join them together so the structure as a whole had strength, not just individual parts. And then the craftsman pig quickly put it all together with the scientist pig telling him what to do and how to do it. And at the end they had constructed the most strong, tough, unbreakable house out of wood that you could possibly imagine. But then they had a problem, of course, because it was a square house and there were only two of them. So one stood at one window on one side of the house and one went to the window on the other side of the house, but Goldilocks came up the other way through one of the other sides, so they didn't see her coming. And she saw the house was too strong to destroy, so she lit a match and burnt the house down and had roasted pig for breakfast. It was delicious. And then after my girl cried a little bit, we said, gee, it's weird because you could easily have all these wonderful skills at knowing how to make things, and you could easily have all this technical knowledge, how to make things properly and strongly and correctly, but you could be solving the wrong problem. You could be thinking the problem is stopping Goldilocks breaking into the house, but the actual problem is stopping Goldilocks eating you, which you can do without breaking into the house, especially if you've made it out of combustible fuel material. So in the third parallel universe, Goldilocks set off after them, but the three pigs all cooperated together. And they ran and they ran and they ran and they ran. And the first pig was a craftsman and the second pig was a scientist, but the third pig was a designer. And the designer said, guys, you're picking the wrong materials to start with. You might have used the right dimensions for the wood, but wood is the wrong material when we're thinking of fire and we're thinking of that pyromaniac Goldilocks girl. We need to make our house out of brick or concrete or something inflammable. Uninflammable. And something non-flammable. Non-inflammable. And so, flame retardant, yeah. So they, he said, I suggest brick or concrete. And then the scientists started straight away going, okay, well, we'll go to Bunnings and we'll get some bricks and I'll look up. And the designer said, hey, whoa. You're doing a lot of effort. But actually, we've just got to solve the problem of keeping us safe from Goldilocks. We don't have to solve the problem of building a house. I suggest we find a house that someone has already built that meets all the criteria, and then we just go and live in that. And that will save us lots of time and money and effort, and we'll still solve the problem just as well. And the pig said, well, that's a great idea. And they said, what sort of place? And the designer said, well, I have a vision. I see we only want to be able to have entrances two ways to this place, because you two are going to be keeping watch while I'm lying in the hammock. So I think we should build it, have it on a bridge over a river. So there's only two possible entrances. And the bridge should be incredibly strong, made out of concrete. And I know where there is such a bridge. And we can build ourselves a little, inside the bridge, we can tunnel and make a little special room for us inside. And someone will have done all the hard work for us, and it meets all our design criteria. And there's only two possible approaches. And that's what they did. And lo and behold, Goldilocks could never, ever find them. So that's a very good story. Do you like that story? But no, the story hasn't finished. Because unfortunately, they had picked a bridge that was being used by the Germans in the Second World War that was just downstream of an enormous dam. So let's just have a look at this. And two British officers have let off some explosives in the dam up the stream. They're the Germans running off the bridge. And the pigs are still looking out the sides, they're not looking up the river. And here comes the water out of the bridge, out of the dam. Look, uh-oh. Oh no. Oh dear. So there you go. And you can imagine what happened. So the problem was that even if you're a good designer, you can still be solving the wrong problem. It's actually quite hard to work out what the right problem is. The right problem wasn't stopping Goldilocks eating them. The right problem was picking a home where they'll be safe from people killing them under any circumstances, no matter who the people are. Does that make sense? So we will see in this course over and over again, we will design solutions to the problem only to realize later on that we have solved the wrong problem and that the real problem is something else. So that is probably the metaphor for the whole course. Has anyone seen that film? What do you reckon? It's quite a good film. Don't like it. What do you think? You do like it?
No, why not just kill Goldilocks?
Oh, why not just kill Goldilocks? You see, well, there you go. There's lots of solutions. Maybe move to another country. Maybe make friends with Goldilocks. Maybe feed her other food. Yeah, well, kill her, I guess, is an extreme one. Yeah, there's got to be lots of ways of solving the problem. That's exactly right. This is the sort of question we should be asking as designers, really. We should be trying to unask the original question and work out what the real question is. Yeah. Okay. So that was the best solution. Now, in the story that I told you, we had three combinations of pigs. We had just the craftsman by himself, and then we had the combination of the craftsman and the scientist, and then we had the combination of the craftsman, the scientist, and the designers. So we had three combinations we looked at. How many combinations are there of the three pigs?
6.
6? 8? Some people think it's 3 factorial, some people are thinking 2 to the power of 3. What's the right answer? Each pig can either be in or out of the combination. How many pigs are there? 2 pigs. So there's 2 to the power of 3. So there's 8 combinations, one of them not involving any pigs. So it's not a very helpful combination. So I didn't look at some of the others, but the others are sort of interesting. We don't encounter them at CSE, but maybe we should talk about them just briefly. Can you imagine a team where you have the designer, but you don't have the craftsman? So you have someone with all the grand ideas and the visions, but they don't actually know how to build it or do anything with it. What's that?
We've all seen the wall building.
The law building. Oh, what's the matter with the law building? Tell it, what's the matter with it?
It was designed.
It was designed, but it was poorly designed?
I imagine the builder was swearing a lot.
Yes, that's right. If the designer designs it not thinking of the builder, is that what you mean? So the designer has no building skills. So what you said, I'll just repeat it for those that didn't see. Imagine the builder was swearing a lot when they had to build the design that the designer gave them. Because it's possible for the designer to come up with some airy-fairy idea, not rooted in reality and not realize how difficult it is. Yeah, spot on. And the reason I want to talk about that is, I guess I just want to sort of briefly mention why we do the courses in the order we do. Like we do C first, then Java. And lots of unis do it the other way. We're a bit of a holdout uni doing it in this order. A lot of unis start with the Java and then do C in later years if you need it. The idea being that Java is more useful for industry and you can do more exciting things more quickly and you can get engrossed in design really quickly. But the nervousness that we all have, I think, at CSE here is that of all the combinations of pigs that we fear the most is probably the loud-mouthed, good-intentioned designer with no practical skills. So we would hate to have, as a boss, someone with all these grand ideas but who we didn't respect technically. We sort of come from a technical background. And the reason I mention that is soon we're going to be talking about something called design patterns. Now, design patterns polarize the software world. Half the people in the world think design patterns are the best thing ever, and they get all excited and vibrate excitedly when you say design patterns. And the other half go, and get really angry and red in the face and start cursing. And I think it's because a lot of people have had experience as programmers of having people come in with design patterns and coming up with all these highfalutin terms and saying we'll do this and we'll do that and we'll use this design pattern. They're just saying crap, and then they walk out, and then you have to build the law building. So if you've been exposed to design patterns before, you might, for that very reason, hate them because you might be deeply suspicious of the technical abilities of the people that use the design patterns to come up with the designs that you have to implement. But I'm hoping by going this way, when we get to design patterns, we are architects who have been builders, and we will use the design patterns and see how wonderful they are in empowering us to come up with more and more complex designs than we'd normally be able to deal with. Okay. All right. Shall we take a little break? Everyone's looking a bit hot. I did have a video I was thinking of showing. The next big topic I'm going to talk about is why computing projects fail. Because the truth is that more than half of computing projects fail in the real world. So more than half of the programming that's done in the world is just flushed down the toilet. Well, I don't know if it's by lines of code, but by counting numbers of projects. And in the old days, it was worse. Something like 3/4 of all software projects failed. Might as well have not started. So after a little pause, we might look at that. I did have a funny video about finding the right problem. Did you want to see that? Yeah. Maybe we'll see that and we'll just have a break for 5 minutes or something like that. All right, this is, well, this will speak for itself. And we want to find here. So that is perhaps solving the wrong problem. Okay, let's just take a break for 5 minutes. Everyone move.